Good evening, Professor. Hope you are doing good. My name is Rupa Goli. I'm going to present a project on free real-time operating system for the spring 2025 semester for the course operating system. Please give me 1 minute so that I can open the presentation right now. So coming to the contents, I gonna discuss these contents in the next coming slides. So coming to the introduction, when discussing about the real-time operating system, which is a specialized operating system, which is used to design, manage hardware resources and run applications with precise timing and high reliability. And also, unlike general purpose operating system, an RTOS is optimized to handle tasks that must be executed within strict timing constraints and also often in embedded systems and critical applications. So RTOS are commonly used in the systems where timely and predictable responses are essential, such as automotive control units, industrial automation, robotics, aerospace, medical devices, and Internet of Things applications, which they allow multiple tasks to run concurrently and ensure that high priority tasks are executed exactly when needed. And also, when coming to discuss about the key features of an RTOS include task scheduling, inter-task communication, synchronization mechanisms, and deterministic behavior. These capabilities help developers build systems that are responsive, stable, and maintain real-time performance even under heavy workloads. So, when coming to discuss about historical perspective of free RTOs, the first one is the origin. Free RTOS began in 2003 for embedded systems. The second one is the evolution and adoption. Free RTOS has grown and it is widely used across industries. The third one is the acquisition by Amazon. AWS brought free RTOS in 2017 for IoT support and also community and ecosystem. So it discussed like free RTOS has an active community and rich resources like that. So it gonna continue development. Free RTOS is continuously updated and relevant. And also at the last, we're gonna discuss about the security features. Free RTOS includes library for secure communication, encryption and authentication, making it suitable for safety critical and IoT applications. So when gonna discuss about the goals and purposes, the first one is the portability across architecture, deterministic real-time behavior, optimized resource uses, scalable design, high reliability, modular and customizable, fast time to market, open source and free, reliability in real-time applications, IoT ready, support for safety certification, efficiency in resource uses. So the next slide we're gonna discuss about standards and platforms of free RTOs. The first one is the POSIX compatibility, which is provides a subset of POSIX APIs to improve code portability for developers. And also the second one is the CMSIS, which stands for Cortex Microcontroller Software Interface Standard. Uh, which interfaces seamlessly with ARM's CMSIS for constant API use across Cortex M microcontrollers. The third one is the MISRA compliance, the coding guidelines followed in safety critical systems useful in automotive and industrial applications. And the last one is the safety certifications, which are divided into ISO 26262 automotive functional safety. Uh, the second one is IEC 61508 Industrial Control Systems. The third one is DO 178C Aerospace Software Certification. Uh, this is the design and implementation of free RTOS as shown here. And free RTOS is designed as a lightweight, versatile operating system tailored specifically for embedded applications. And also its architecture centers on a kernel that efficiently produces the scheduling and intertask communication. And also this framework ensure optical performance even in resource constant environments, making FreeRTOS a popular choice for a wide range of embedded systems. And in implementation, FreeRTOS prioritize modularity and adaptability, allowing seamless integration into diverse hardware platforms, where developers can fine tune the operating system to match the unique records of their projects through its configurable features. And also, additionally, FreeRTOS offers a user friendly API that simulates task management and synchronization, streamlining the development process, where the combined with testing and community support, FreeRTOS enables developers to create robust and efficient embedded applications that meet real-time performance demand. So moreover, FreeRTOS offers seamless integration with hardware abstraction layers like HALS, which allows developers to target a wide variety of microcontroller architecture without significant changes to the application code. And also, when coming to discuss its open source nature, FreeRTOS fosters a collaborative ecosystem where developers can contribute improvements and share solutions, ensuring continuous innovation and support. This adaptability and community driven development make FreeRTOS a reliable choice for both simple and complex embedded systems, ranging from IoT devices to automotive and industrial control systems. There are two types of components of FreeRTOS. One is the task and the scheduler. Task means smallest unit of execution, independent threads, and the scheduler determines which task to run based on priority. So this is the image of the memory allocation that I have shown in the picture, where the RAM is going to allocate the memory in the task 1 and task 2 memory blocks, where interrupt handling mechanism for handling interrupts and interaction with the task. Like we in the picture we gonna have the priorities ranging from 1 to 7, which interrupts using these priorities will never be delayed by anything the kernel is doing, and also can nest but cannot use any FreeRTOS API. These are the priorities for the priority 4 to the priority 7. And when coming to discuss about the priority 1 to 3, it's like interrupting that makes API calls can only use these priorities, can nest, but will be masked by critical sections. And also from the priority 1 to the 7, which interrupts but don't call any API functions that can use any priority and willness. So the next slide is about interconnection of subcomponents. The first one is the memory management, where FreeRTOS provides multiple memory allocation schemas, including static and dynamic allocation, suitable for constant embedded systems. The second one is the tickles mode. It supports tickles idle mode to reduce power consumption during system idle periods. The third one is the timers. It includes software timers for delaying or periodic task execution. The next one is the portability, which is FreeRTOS is portable across a wide range of microcontrollers and processor architectures. The next one is the modular design, which has a lightweight and modular architecture, allowing developers to include only necessary components. The next one is the support for priority inheritance. This helps prevent priority inversion issues in critical sections. And but the last second one, like a real-time performance. which ensures deterministic behavior critical for hard real-time applications. And the last one is the community and commercial support, where free RTOS has a large user community and is backed by AWS for long-term maintenance and integration with IoT features. The next slide we're going to discuss about the complexity and cost of implementation. The first one we're going to discuss is about the complexity. Debugging concurrency issues can be challenging, especially with multiple tasks and sharing resources. Integration with external perhaps may require low level driver development, where developers need a good understanding of real time concepts to optimize task performance. Timing and synchronization bugs are often subtle and hard to trace. When we are gonna discuss about the cost, the first one is the training team members on RTOs. Concepts may initial time and resource cost. The second one is long-term support and maintenance of free RTOs based systems add to operational costs. And the third one is costly mistakes can arise from poor task design or memory mismanagement. Using advanced third-party debugging or monitoring tools may involve licensing tools. The next slide, we're going to discuss about the pros and cons of free RTOs. The first one is open source with no licensing fees. The second one is the real-time capabilities for predictable task scheduling. The third one is portability across various microcontroller architectures. The fourth one is scalable from simple to complex systems. And the last one is active community support. And also, when discussing about the cons, like limited advanced features compared to commercial solutions, learning curve of for newcomers, and also the third one is like the debugging challenges may arise, resource usage can be higher, and also the limited official technical support options. The next slide, we're gonna discuss about the companies involved in free RTOS. Here these are the companies that was involved with free RTOS. Some of them like AWS, ST Microelectronics, NXP Semiconductors, Texas Instruments, Microchip Technology, Renesas Electronics, Cypress Semiconductor, ARM, and last one is the Esprif Systems. The next slide, we're gonna discuss about future trends of free RTOS. The first one is deeper cloud interaction, continued expansion of Amazon free RTOS, free real-time operating system features for seamless AWS IoT and cloud service integration. The second one is enhanced security, which is used to build in support for secure boot, encryption, TLS, authentication mechanisms. The third one is IoT centric enhancements, better support for MQTT, COAP, and lightweight M2M, which was LWM2M protocols for constrained devices. The last one is the improved tooling and debugging, integration with advanced visualization and trace tools. Uh, at last, we're gonna discuss about the conclusion, where free RTOS continues to be a corner side in real-time embedded systems developed due to its open source nature, lightweight design, and real-time capabilities. Its flexibility, broad hardware support, and strong community make it real-time for a wide range of applications, from simple embedded devices to complex IoT ecosystems. While it may not match every advanced uh, feature of commercial RTOS solutions, its simplicity, portability, and reliability offer developers a robust foundation to build responsive and effective systems. And also, as embedded technologies and IoT continue to evolve, free RTOS is a well positioned to adapt and thrive, making it a future-proof choice for embedded software development. This is the references that I have used the PDF. And thank you, Professor. Thank you for giving this opportunity.